And today what we are looking at is other means, other averages, and these are called weighted means. And I've changed some of the wording here, but it essentially matches your handout. In a weighted mean, the data is not treated equally. And there's a classic example of this that you're familiar with. I collect data from you this semester. So far, I've got about 10 data points. We've had 3 or 4 assignments, 2 or 3 quizzes, a couple of exams. So let's say I've collected 10 sets of data. I have 10 marks for each of you. When I calculate your average, which is what goes on a report card or what the average is in your PowerSchool account, do I just take all of those numbers and add them together and divide by 10? No, because you know exams are worth more. They're weighted heavier. That's where the word weighted comes from. For example, a teacher, myself, might assign different weights to different parts of your grade. Assignment, and these are not the weightings that I use in this class, but assignments might be worth 45%, quizzes might be worth 15%, and the final exam might be worth 40%. And I want everybody to take a minute and add these numbers together. And you get 100%. And anybody who's calculating a weighted average for school marks, and they're doing it right, needs to set it up so it adds up to 100%. Otherwise, those percents are meaningless. If it only adds up to 80, then that 40 is not really 40%, because it's got to be 40 out of 100. In each case, each of these data points is only worth a percentage of the total that you use to calculate an average. And this is probably the trickiest part of this section that we're in right now. So we're going to do on page 125 the example. And there's room on the top of the next page for you to continue your work here if you need it. So Frida earned grades of 85%, 72%, 65%, and 90% on 4 tests in her math class. So if each test were worth the same percentage, what would her final grade be? So we're imagining a very simple situation. There's only 4 marks she gets. And the teacher's going to look at those 4 marks and is going to calculate her final grade. I hope you see that what A is asking you for is the mean, the average. Not trimmed, not weighted, just the regular run-of-the-mill average. So how would we do that? Well, we would take 85% plus 65% plus, I missed one, 72% plus 90%. And you all know that the order you add these in doesn't matter, right? So I missed the 72. I threw it in third. 85, 65, 72, and 90. And we would add those together and we would divide by 4. Why 4? Well, because there's 4 marks that we're averaging. So I'll give you a minute to do that, please. I want to say 73, but I just rolled that around in my head. No, what is it, Brendan? 78? 78? 78? Okay. So her final grade would be 78%. The next question is a little different. It says, what if they were weighted? So the first test, the 85%, which is the first test, is only worth 10% of her final mark. The second and third, the 72% and the 65% are worth 20% each. So in fact, I changed my mind about how I want us to write this. The second test, which she got 72 on, is worth 20% of her mark. The third test, which she got 65% on, is worth 20% of her mark. and just before we go on, and this can get tricky, how many of you understand that the second test is worth more than the first test? I mean, it's clear, it's worth 20%, the first test is worth 10. What that means, forgetting about number crunching and doing some calculations, is it's not as important how she did on the first test. If she got only 40% on the first test, but got 90 on the second, that 40 isn't going to really affect her mark as much as if they were all weighted equally. Okay? And let's just see here. What does that add up to for the total percentage towards her mark so far? Does it? Add these up. 50. And that explains why the final test is worth 50%, right? So this final test that she got 90% on is worth 50%. Now, how do we go about finding an average here? We are not, there are ways to do it this way, but we are not going to. We are not going to start adding things up and dividing by a total number of items. That doesn't work. What we're going to do, and this will only work if these add up to 100%, is we're going to find out what 10% of her mark on the first exam is worth. Think about this. If 10% of her final mark comes from that first test, then we need to find out what 10% of that first test is. So how are we going to do that? Well, 10% means 10 over 100, and then we need to multiply by 85. That's what percent means over 100. And you're going to do the calculation for me and let me know if you get 8.5%. You do, okay. You know what this means? This means that if this student, Frida, this means that if Frida got 85% on her first test, and then for her final 3 tests, she got 0, her final mark would be 8.5%. I don't know why Frida would do that. But what this means is that Frida has already put into her final mark 8.5%. She's already here, this 8.5. She's got a ways to go, right? Now, if the second test is worth 20%, then we need to figure out what 20% of her mark on that second test is. I'm going to switch to decimal. I'm sure you remember that 20% can be written as 0.20, 10% 0.10, 50% 0.5. So to go from percent to a decimal, you just move the decimal 2 places. So we need to multiply that by her 72% to find out how much that mark is contributing to her final mark. And I'll give you a minute to do that calculation. And confirm that you get 14.4. I think you're getting the drift of how to do this. The next one would be 20% of her mark. So that would be 0.20 times 65%. And I'm getting 13.0. Let's just take a break here, a pause, a breather. Can you add up these three amounts that she's accumulated so far? 8.5 plus 14.4 plus 13.0. And tell me what you get. 35.9. 35.9. So, you don't have to write this down. I just want to talk to you about the numbers. She has written 3/4 of her exams, hasn't she? And she did pretty good on those exams, didn't she? And yet, if she didn't write the 4th exam, she would fail the class. Why? Because the 4th exam is worth so much. So this 10% and 20% and 20% for the first 3 did give her some credit mark-wise, but she's got that big exam left, so that's going to be the one that counts the most. That's going to be the one that really bounces her mark up, especially considering she got 90% on it. So we need to find out what 50% of 90% is. That's 0.5 times 90. I mean, this is what I'm talking about. That's 45, isn't it? Like that test alone gives her 45% towards her final mark. That test alone gives her more towards her final mark than the 3 before that. And all we do now to find out what the class mark will be is we add these numbers together. I'm getting 80.9. You as well? Good. I've taught in a number of different schools over the years. We always round to the nearest percent for final marks. So Frida's final mark here would be 81%. It can get trickier than that. And what I would like you to do right now, maybe I will pause here for a second. Does anybody have any questions with what we did there? Okay, so I will tell you, this is not something you want to just do on your calculator. You need to organize your thoughts nice and clearly like we did here. Okay. What I would like you to do now, and I want to just click ahead here and see. We're going to take a look at page 126. Because in a few minutes, well, maybe about 15 minutes, you're going to be assigned your daily work, and one of the questions will be this one. Let's read it together, and I want to help you out. We're not going to do it together. You're going to have to do it on your own, but there's something about this question that's a little bit different. So Karina is calculating her final grade in Spanish class. Assignments are worth 15% altogether. Altogether. They're not 15% for each assignment. Okay? They're worth 15% altogether. And what we can assume here, everybody, is since there are 3 assignments, that each one is worth 5%. There's another way to do this problem, but I don't want to get into it today. All right? There are 3 assignments. If the assignments are worth 15% altogether, then each is worth 5%. 5 plus 5 plus 5 is 15. Now, look at what they're doing. This is how important the wording is. With the 15%, it's 15% altogether for the assignments. With the quizzes, it's each quiz is worth 5%. So this is worth 5%. This is worth 5%. This is worth 5%. You might think, as a math teacher, whoever made up this question, they're being a little cruel because they're switching gears here. They're telling you, Well, assignments are collectively worth 15%. The quizzes, however, are worth 5% each. The presentation is worth 25%, and the final exam is worth 45%. So I have up here 1, 2, 3, 4, 5, 6, 7, 8. Excuse me. I have 8 numbers, weightings. What do they add up to give? Better add up to give 100. Do they? Do. So here's what you need to do, though. Give me 1 second. When you take a look at that example we did, we knew the percent that Frida got on each of these. We don't know that. What you need to do here is figure out what these percents are. So if you got 8 out of a 10 on a quiz, what percentage is that? 80, right? Or you could go 8 divided by 10 times 100. But her quizzes, well, I guess those are assignments, are 80%. Can you figure out what 6.5 out of 10 is as a percent? 65. A lot of these numbers we don't really need a calculator. 16 out of 20. I believe it's 80. I think 16 out of 20 is 80, isn't it? Okay. And what are the weightings here? Five percent, 5%, 5%. So I'm setting this up in the same visual way that we did the example. What'd she get on her presentation? $85. I mean, do we really need to use our calculator to know that 85 out of 100 is 85%? I sure hope not. And that's weighted at 25%. We also have a final, and then we have those 3 quizzes. So her final exam she got 86 on, and it's weighted at 45%. And the quizzes are 100, 70, and 70, weighted at 5% each. I better double check that. 100, 70, and 70 at 5% each. Now, that's kind of where we're going to end, because this is going to be one of your assignments, okay? Assignment questions. But I want you to just take a look up here for a minute and listen to what I'm about to tell you. Is there a simpler, you're going to have to find out what 5% of 80 is, and 5% of 65 is, and 5% of 80, 25% of 85, and continue, and then add them all up to find her mark, right? Is there a simpler way to tackle the quizzes and the assignments? Yes, there is. What you could do is you could find her average quiz mark and then multiply it by 15%. If you want to take that shortcut, that's fine. I want you to be able to get the right answer. That's the most important thing. And my experience with this class, and I've taught it a few times now, is that this is what students like to do. Each item is weighted. Okay? So, just to go back, and I'm doing this because Daniel, you just came in. I want to quickly go through this. On example 2, Frida earned grades of 85%, 72, 65, and 90. And what we did in example 2A is we found the average. No problem. And I'll put this back up at the end of the lesson so you can copy it. So don't try to furiously copy it. No problem. That's not what we're talking about. In reality, her mark is calculated based on different weightings. That the first test is worth 85%, or the first test that she got 85 on is worth 10%. She got 72 on the second, which is worth 20, 65 on the third, which is worth 20, and the last exam she got 90 on, which is worth a whopping 50. How do we find her, quote, average? What we do is we find out what 10% of 85 is, and that mark goes towards her final mark. We find out what 20% of 72 is, 14.4, and that goes towards her final. And we do that for every item, and then we add it up. Okay? There's one other example I want us to work on here today. And what we're doing now is looking on page 127. So we've done weighted averages, and now we're going to be looking at averages where you have multiple items that are the same. So Glenna is a server in a restaurant. On a particular shift, she had 2 tips of $6 each, 3 tips of $8, 3 more tips of $10, and 6 tips of $12. What's her average tip? And you know what? I'm going to give everybody a minute, couple of minutes, 3 minutes, 4 minutes, whatever. I want to see if you can find out what her average tip is from that information. And because this is money, we want to round an answer to the nearest hundredth. Have you got it? Yep. Exact. Okay. Have you got it, Brendan? Jackpot. Perfect. And I like that the first 2 people who got it, Alexa and Brennan, you got them in different ways. What you did, Brennan, is different than what you did, Alexa. I think. You did the same thing I did. Exactly. I'll show you. Like, exactly. Right? I didn't even use a calculator to find those. I just knew them like you knew them. So, the answer is $9.86. It's actually 9.8571 something. And what Brennan did, and we're going to answer this question now. It says calculate the mean tip using 2 different methods. So I'm going to show you Brennan's method first, and you don't have to write it down because you've already done it. What you did was you said 6 plus 6 plus 8 plus 8 plus 8 plus 10 plus 10, plus 10, plus 120, plus 12, plus 12, plus 12, plus 12, plus 12, plus, I'm just going to squeak in that last 12, I think. Is that your approach? Okay, and then you divide it by, when we count them up, we have 2, 4, 6, 8, 10, 12, 14, and you get 986. Okay. This is good, but there is a slight disadvantage with doing this. That imagine it weren't tips, but it were instead money put in a savings account over a period of 5 years. And this is the amount of money you put in every week. What if it were 320 of those weeks you put in $12 each week? With this approach, then you'd have to write plus 12, plus 12, plus 12, plus 12, plus 12, plus 12, plus... I'm not going to count them off to 320, but there would be a lot of them. And that leads to the method that I happen to use and Alexa happened to use, is we recognized that rather than saying 6 plus 6, this is 2 times 6. Rather than saying 8 plus 8 plus 8, it's 3 times 8. And what's interesting here is once you read the question and understand this, it's pretty easy. 2 times 6, 3 times 8, 3 times 10, 6 times 12. Instead of doing that, we could have written 2 times 6 plus 3 times 8 plus 3 times 10 plus 6 times 12 and divided that by 14. And I do want everybody to do that. Did I write something down wrong?
No, Seth. I did that one on the paper, but I did the way you're doing it right now on the calculator.
Oh, that's interesting then. So what Brendan's saying is he wrote this down. That's what you're saying. But when it came to calculating it, he calculated it this way. Perfect. Even better. And by the way, Alexa and I did the exact same thing. We didn't even write this down. I don't know what you wrote down. I'll show you what I put in my calculator. I just did this. $12 plus 24 plus 30 plus 72. Now, you happen to know that 6 times 12 is 72, and I happen to know that 6 times 12 is 72. You might not know that, so you might have to use a calculator. But the important thing is we're multiplying the 2 by the 6 to get 12, and then we hit enter, and we go divided by 14, and there's our answer. So we've learned 2 things today. Weighted averages or weighted means. I like to call them weighted averages. And then averages when you're dealing with multiple items. So on page 126, 4 and 5, and those are going to be problems dealing with weights in averages, or weighted averages, or weighted means. And then a few more questions, some dealing with multiple items, some dealing with other items, on page 128, 7, 8, and 9. This takes us to the end of the second section in this unit. We still have chapter section 3.3 to go, and we'll start working on that tomorrow. And Daniel, what I'm going to do